Hello everyone, welcome to Jigyansa Educations. In this video, we will discuss the chapter 12 of NCERT of class 10th, and the topic is areas related to circles. So first, we will discuss about the perimeter, and then we will discuss about the areas related to some parts of a circle. So let's understand what is perimeter. The distance covered by traveling once around a circle is its perimeter, usually called its circumference. So when you just travel once over the circle, over the circumference, that length is called the perimeter of the circle. So circumference is equal to pi into diameter, or you can say it's pi into 2r, where r is the radius. So circumference is 2 pi r, and we can say that perimeter is also equal to 2 pi r. Now to calculate the area, we take pi into r. So pi r square is the area of the circle, where r is the radius. Now we will solve an example. So it's related to the circumference and as well as the area maybe. So let's see what the problem is. The cost of fencing a circular field at the rate of 24 rupees per meter is 5,280 rupees. The field is to be ploughed at the rate of 0.50 rupees per meter square. It's 2 is meter square. Find the cost of ploughing in the field. So see, we have to fence a circular field and we have to plough a circular field. So while doing fencing, you have to cover the boundary. So the boundary is the circumference. So we have to calculate the perimeter. And while when we go for plough, then you just can say for cultivating, we cultivate the whole area. So we should calculate the area here. And for perimeter, you know what is the formula. So you just can find it out that if 24 rupees per meter is needed and the total cost is 5,280, then you can divide it by 24, then you can get the circumference, the length of circumference, and the same way you can get the area. I mean, here it is given 0.50 is the rupees per area that is needed. So from here you have got that the circumference is 5,280 divided by 24, so 2 pi r is that much. Then from there you can calculate the radius, and once the radius is calculated, then you can find out the area, and it is given that 0.50 rupees is needed per meter square. Then you can calculate how much will be the cost. Now we will discuss some important concepts related to sector and segment. So it's here we will discuss how to find the areas of a sector and a segment of a circle. So what is a sector and a segment, I have discussed in chapter 10. So if you have not watched, then you can just go and watch the first part of that video and see. The sector, you can see that on this circle A, O, B and P. Suppose this is the center. I take 2 points on the circle. I connect A, O and B, O. Then you can see that A, O, B, P. I mean this part. When I separate this part, also we get another complementary part, right? So based upon the size, we can say that this is the minor sector and the other thing is the major sector. But you just understand that when normally we are saying this is the sector A, O, B sector, that means I am always indicating the minor sector. Okay, and the same thing is for segment. When you draw a chord, then you see that that chord and the arc that is connected to that chord, that forms a segment. And here also you can see, once you draw a chord, it divides the circle into two segments. One is a minor segment and another is a major segment. So again, here also when we say normally segment, that means we are indicating the minor segment. Now let's calculate how to get that area of a sector of a circle. So we will understand how to get the formula to calculate the area of a sector of the circle. See, this is the circle, O is the center. Now I am connecting A, O, B. A, B are 2 points. To get a sector, I am just connecting these things to center. Now A, O, B, P is my minor sector, and it forms an angle of theta degree at center. Okay, so AOB is theta, the radius is r. Now let's understand how to get the area of this segment, this AOBP. So area of the circle, we know the area of the circle, the whole thing is pi r square. So if you know, when you draw a circle that is OA, we keep rotating this line around it, and when it reaches its initial position, then the circle is completed, right? So we draw this OA and we try to drag this OA around the center, then we get that circle. So can you see that this line is making 360 degree at the center? This OA, if I'll try rotating it around, then it makes 360 degree around the circle. So for 360 degree we are getting pi r square, the whole area. So an angle of 360 degree is drawn at the center by pi r square areas. So 1 degree can be drawn at the center by pi r square divided by 360 degree. For 360 degree it is pi r square, then for 1 degree it is pi r square by 360 degree. Then for theta degree it will be pi r square by 360 into theta degree. So the area we can calculate by using this formula, that is theta by 360 into pi r square. So the area of a sector of angle theta. So this is a sector with angle theta, that is theta by 360 degree into pi r square, where r is the radius, theta is the angle of the sector in degrees. Then how to calculate the area of the major sector? See, when we are just drawing a sector, then you get another sector, that is the major sector, that is complementary to the minor sector. So to calculate the area of the major sector, you have to simply take the total area of the circle and you have to minus the area of the minor sector, then you will get the area of the major sector. Now how to calculate the area of a segment of a circle? So you understand that what is a segment? Segment, like when you draw a chord, then it divides the circle into two parts. One is a minor segment, another is a major segment. Now let's understand how to calculate the area of a segment. So see, here you can see AB and P. This is a segment. So to calculate this, I will always draw a line connecting center to A and again connecting center to B. Then once you can see OAB is drawn. Now you can see OAPB is a segment, it's a sector, and we know the formula for the sector. So you can find the area of OAPB sector. Now OAB is a triangle. Now you have to apply your mind and you have to find out what is the area of this triangle, because the triangle can be different ones, right? So it can be a right angle triangle, or on different basis we may get different kind of triangles. So you just apply your intelligence, you just apply your mind and just try to find out how easily we can calculate the area of this triangle. So the area of the major sector is area of the circle minus area of the minor segment. So the area of the segment can be calculated by calculating the area of the sector minus area of the triangle you get inside that. Now example. So it is given that find the area of the sector of a circle with radius 4 and angle 30 degree. Also find the area of the corresponding major sector. So theta is given 30 degree and the radius is 4. Now you can just apply those things in the formula and you can see you get it. 30 divided by 360 into pi, in place of pi it is 3.14. Now into 4, then you calculate and you get. And for the major sector you have to calculate the whole area of the circle, that is pi r square, and minus the area of the minor sector. Now we go to the next example. It is find the area of the segment AYB. It is AYB, this segment, and the radius is 21 centimeter and AOB is 120 degree. So see, here you again draw the lines and you see it is 21, it is 21, it is 120 degree, and you just apply the formula to get OAYB, the area of OAYB. Then try to calculate the area of this triangle. So it is 21, 21, and if you want we can calculate this what is the length of AB. So you can just apply your concepts related to trigonometry to find out what is the length of AB. Once you know all the sides of the triangle, you can always calculate the area using the formula, right? Now see, here it is written how to get the area of this triangle AOB. Just go through that. It is just the application of the trigonometry. And let me just give you a short brief. You can see AOB. So you try to draw a perpendicular from O, and then it bisects the angle AOB. It becomes 60, 60, it's 90, 90, then obviously this is going to be 30. Then you just use, this is 21, this is 21, then you can apply the cos theta thing, cos 30 cos theta or sin theta, to find out what is the length of AM and BM. Then you just calculate and see what the results you are getting. So now we will just I will explain how to solve the problem. You just try out these things at your home. So you can see the figure here, that you can see it's a square, right? So ABCD is a square and one side is 56 meter. Now you can see there is some circular arc at AB and there is another circular arc at DC. You just can go through that question, that is two circular flower beds have been sown on two sides of a square lawn ABCD upside 56 meter. If the center of each circular flower bed is the point of intersection of O of the diagonal of the square lawn, find the sum of the areas of lawn and the flower beds. So you can see that it is saying if the center of each circular flower bed is the point of the intersection, that is O is the point, that is the center of this circular flower bed. So you can say that this O, A, B, O, this is a segment, and you know this is 56. Then you can calculate the diagonal by just multiplying with root 2. Then dB is root 2 into 56. Now you can just find what is OB. This is just half of that, and this is also same as OA. So you know what is OA and what is OB, and just before that you just can see that the two diagonals they intersect each other at 90 degree. So AOB is 90 degree. So you can find out what is the area of AOB segment, I mean this segment. Then you can calculate the area of this triangle, and you can subtract the triangle area, then you can get the area of this circular flower bed. And this is similar to this one, you can just multiply with 2 to get the area of the both of the segments, and you know how to calculate the area of the square. So I think that will help you to solve the problem. Then the second problem is, here you can see there is a square ABCD and each side is 14 centimeter, and we have just drawn 4 circles touching each other and also touching the sides of the square. Now we have to calculate the area of the shaded part. Okay, so for that what we can do, we can find out the area of the square ABCD because sides are given, and the area of the square is side multiplied by side. Now how to find out what is the area of these circles? So if you will draw a line that connects the center, the point of contact here, then again the point of contact here, the center, then again the point of contact here, that will be on the same line, right? So you can see that the diameter of this circle and the diameter of this circle, so both of the diameters adds to make one side of a square. So this is this diameter plus this diameter is 14 centimeter. Now you can just find out what will be the single diameter, maybe, I mean what can be the single diameter, what can be the radius then, and what can be the area of a single circle. Then you can just find out what is the area of all the 4 circles and just minus the area of the circles from the area of the square. So that's it, and you will get the area of the shaded part. So that's about for today's class, and we will try to bring up more solutions to more interesting problems so that you can improve your logical thinking. So thank you very much for watching this video. So see you in the next class. Thank you.